Teacher, we are currently allowing all the participants to coming in first, and
Okay, sure.
we will start sharp at 3 p.m.
Okay, sure.
Okay.
All right.
Okay, let's begin. Okay, good afternoon.
Good afternoon.
Welcome everyone. I'm Marian from Utah. I would like to welcome to today's virtual symposium on Science Education 2020. The title of our symposium today will be Green Box, Reuse Burn Fluorescence Light to Manage Mercury Pollution. Okay, before that, I would like to remind you, if you have any question, please leave your question at the chat box. We are streaming this virtual symposium live on our Kuala Lumpur Engineering Science Fair Facebook. Please help us to like and share this video. So I would like to also introduce today's speaker. It will be Mr. Sri Ganapati Krishnan. He is the winner of Science Education Award by Malaysia Torre Science Foundation MTSF 2020 and also Gold Award 2019 International University Carnival on e-learning. Okay, now without further ado, I would like to turn over the time to Mr. Ganapati. Over to you, sir.
Thank you, Madam Marianne. First of all, thanks to Kuala Lumpur Engineering Science Fair Committee for this opportunity. Hi everyone. I can see some of my students are here. Okay, my name is Sri. You can address me Cikgu Sri. Okay, my topic is Green Box. Okay, at the end of this presentation, I hope all of you will agree with me. This Green Box concept will help to manage mercury pollution at the same time benefit school students. Okay, we start with the slides. Okay, every innovation begins with a problem statement. Mercury is a chemical element and a heavy metal commonly used in various industries. Okay, this heavy metal has special concern. It has tendency in causing many serious impact on human health and the environment. Okay, so mercury with atomic number 80, atomic mass 200. Okay, if you look at this picture, this is Mercury cycle. Okay, basically all the mercuries will end up in river. Okay, so what happened in the river? Okay, so the mercury will undergo few process. Okay, the process flowchart is here. Okay, begin from inorganic mercury discharged to the water or sediments or river. It will undergo biomethylation. Okay, or we call it a biotransformation. Means mercury become methyl mercury. Okay, this is we call methyl mercury is organic mercury. So this methyl mercury accumulates in edible fish in river and also ocean indirectly to human. Okay, when we eat fish. Okay, maybe all this while we assume that the fish that we eat don't have mercury. We don't know actually. Okay, which supposed to be less than 0.5 milligram per kilogram. Let's say a fish is 1 kg, it must be less than 0.5 milligram of this methyl mercury. Okay, if you look at this world map, okay, mercury emission. So Asia is one of the highest. Okay, you can see 10 to 500 grams kilometer square. Okay, that is a lot actually. So if Malaysia also around 10 to 100 gram per kilometer square. Okay, according to Department of Environment. So waste, this is the e-waste list. Okay, so if you look at the mercury, it caused damage to brain and nervous system. Okay, it started in Minamata, Japan in 1953. Okay, 1953, this is the first case. And then up to 1971 in Iraq. So until today it's ongoing. Okay, but it's not very serious. Okay, so this is a video. Okay, a video about Minamata case. Okay, Minamata tragedy. So before I start this video, I would like to inform that this is 18 SG video. Okay, so this is only for educational purpose, not for entertainment. Okay. In 1908, he purchased a Lotus factory in Minamata, a small fishing village. Okay, so the video is for awareness purpose. Okay, I'm very sure this is a very serious issue that we have to tackle from now, since we are surrounded by most high mercury emission countries. This is not COVID-19 that we can close boundaries. Okay, this pollution can cross the boundaries. Okay. Okay, so green box. Okay, before we go to green box, okay, we go through the products, okay, that use mercury. Okay, so we focus to the waste from the products. Okay, so look at these two tables. Okay, so the first table is mercury consumption, which is about 135 metric tons, and mercury that released to the atmosphere from this 135 is about 13 metric tons. Okay, and we can see South Asia, the consumption is about 36 metric tons. This is not small amount, it's a lot. Even this 13 metric ton, which is released to atmosphere. Released to atmosphere means like they are not handled properly, released to the rivers. Okay, so we can divide the mercury emission into two. Okay, one is intentional source, another one is unintentional source. Intentional source is like we know, okay, we know the purpose of we use mercury, like thermometer. Thermometer use mercury, so we use mercury for thermometer. So that is known as intentional source. Unintentional is like a volcano eruption, okay, coal plant, all those are unintentional. So our focus is intentional source. Okay, so in intentional source, we can classify into seven types in medical, switches, batteries, fluorescent lights, measuring devices, and biocides. Okay, so our focus is to fluorescent light. Okay, so the green box is to overcome one intentional source, which is burn fluorescent light. Okay, so if you look at the picture, I show this CFL, compact fluorescent light. Not only compact fluorescent light, all the fluorescent light that contains mercury can use with green box. Okay, so what is inside CFL? Okay, so if you look at the CFL, so it contains argon gases, okay, of course, mercury vapor, and you have pentaflow, okay, or pentaflow coating or phosphor coating, okay. So when electric pass through the gas will excite, okay. So especially the mercury vapor will excite, it will produce UV, ultraviolet. So this ultraviolet will change by phosphor coating to visible light. So this is how a basic, compact fluorescent light function, similar to the fluorescent light, the longer type, and all the fluorescent light, similar function. Okay, so normally burn bulbs are because of this part. Okay, we have a PCB board. This is called ballast. Okay, normally the ballast will spoil. Okay, that's how we will throw these bulbs away. Okay, so this is the ballast. So for green box, we don't need this ballast actually. So I'll show you in a video later. Okay, fluorescent scrap. Okay, fluorescent scrap in Malaysia. This is our common practice when we change fluorescent light. Okay, definitely it will be end up in dustbins, and most of it broken. Okay, mercury will release to atmosphere. So we don't really keep all these bulbs in the house. Okay, because we don't know how to use it back. Okay, few million bulbs are in the rubbish every year. Just imagine one bulb will have 5 to 13 milligram of mercury. Okay, just multiply with millions. That's a lot actually. Okay, and also recycle these bulbs also very expensive. The process is very expensive. We need a lot of bulb extractor. Okay, we do have bulb extractor in Malaysia, and I don't think so it's enough. Okay, it's enough to extract all the bulbs. Okay, so we need to have a kind of SOP. Okay, standard operational procedure. Okay, to handle these burn bulbs. Okay, next. Okay, so I would like to introduce to green box. Okay, now I'm going to play a video. So this video is from my student. Okay, they produce themselves. Okay.
Mercury is a chemical element and heavy metal commonly used in various industries. Moving along as a consequence of rapid industrialization, that uses birds to produce the light.
Okay, how's the video? So this is 100% produced by my students. So they only get a few video footage from me. So the rest all is theirs. Okay, so this is how they learn. Okay. So in school, we already have two types of transformer in Form 3 syllabus, Form 3 science syllabus, which is step up and step down. Okay, so we introduce a new type of resonant transformer. Okay, resonant transformer is like step up transformer, but the difference between the resonant transformer and the common transformer is the one in the school we use iron core. Okay, this will use air core. So this is the difference. So I wish one day all the school will have this resonant transformer. Okay, so then the student will know, okay, what is resonant transformer. But basically, when I said resonant transformer, this is a Tesla coil. I don't use the word Tesla coil because Tesla is a brand, is a patented. So I prefer to use resonant transformer. Okay, so this is my first model, my first resonant transformer I tried with my students. Sorry. Okay, battery with Swiss and then transistor. Okay, I'll show you the transistor code later. Connected with the resist, sorry. Swiss transistor, resistor. Okay, this is the solenoid, or we call it coil. So if you look at this, it's not connected to the power supply. So this was the first resonant transformer I did with the help of STEM club student. Okay, so this is a simple diagram, so that student can understand. It's not sophisticated diagram, very simple. Okay, so green box has few components, very important components. The first is transistor. So when we use transistor, we have to be careful with the connection because we have 3 poles here: collector, base, and emitter. Has to be correct. Okay. Next component is resistor. So we call a 22K resistor. Some of the resistors are not in brown in color. Okay, some are in blue or green. It depends on the brand, but the codes must be similar, which is 22K. Next, we need switch, single way or two-way switch. Okay, and then a copper wire. This copper wire we can get it from a school physics lab. Okay, preferably 0.22 to 0.30 millimeter. Okay, if you use 0.30 millimeter with 8 cm PVC pipe, which is half inches diameter, will give you 260 to 280 turns. Okay, and connecting wires. This is 15M connecting wires. Normally we use for lighting purpose. And then PVC pipe. This PVC pipe not too big. Okay, half inches is just nice. Okay, half inches, and length is 12 cm or 10 cm, depends how many turns you need. And a plastic ball, we use ping pong ball, very easy ping pong ball, and aluminum foil to wrap the ping pong ball. So this function as a capacitor in resonant transformer. Okay, so how to make resonant transformer? Okay, so this is a step by step. So I will pause and explain. So this process will take time, at least 1 to 2 hours, because you cannot overlap the copper cable. Has to do it very slowly. Imagine it's 270 turns if you use 0.3 mm. Okay, most important is don't overlap, because if you overlap, the flow will be different. Okay, sometimes it won't emit the electric field. Okay, the base must be in wood. Okay, don't use metal. Okay, so metal will conduct the electric later. Okay, so this process is very important because we use transistor which don't have the heat sink. So when you use soldering iron, make sure solder for short while. Okay, don't let it too long touch contact with the transistor's leg or body because it will damage the transistor later. Okay, so sorry. Oh. Very sorry. Okay, so this is called primary coil. Okay, so maximum turn is 2 to 3 turns is enough. Okay, so 2 to 3 turns primary coil, and you have 270 secondary coil. So if you use 0.3 mm copper coil. Okay, so without the ping pong ball wrapped with the aluminum foil, it still can turn on. But if you use the ping pong ball with the aluminum foil, the brightness will be different because it will act like a capacitor.
Capacitor 我ambil di mana? Resistor ah, 我ambil. Capacitor ah.
Okay, so it looks very simple, right? Looks very simple. You must try first because the most important is the solenoid. Okay, cannot overlap. The rest all is fine. And then when you solder, don't contact too long because the component will damage. Okay. So next, so once we have the resonant transformer, we have to get ready the bulbs. Okay, burn bulbs collected by the nature club. We can use a school nature club to collect burn bulbs. We can use this bulb directly but we don't use the ballast. We only want the tube. Okay, so we dismantle. The STEM club members will dismantle all the bulbs until we have this alone. Okay, so the bottom ballast we can send for the e-waste. Okay. All right, so once the light is ready, we design a casing for resonant transformer. Okay, so this casing also designed by student. Okay, we draw with the AutoCAD and then printed with the 3D printer. So a 3D printer will cost around 30 cents to 60 cents per kg. Sorry, not per kg, per gram. Okay, 30 cents to 60, 30 to 60 cents per gram. So this will cost around 20 to 24 ringgit. Okay, this box is around 42 to 45 grams. Okay, so once the casing is ready, the resonant transformer placed inside the casing. Okay, so if you look at this resonant transformer, this is the compact design. Okay, designed for this year 2020. Okay, so this will have heat sink. Like I said, the earlier transistor don't have heat sink. Okay, so this transistor with heat sink, okay, can last longer compared to the earlier one. Earlier one, if you on, and it will last for maximum 3 hours, but with the heat sink you can use for years actually. Okay, so this is how my school, okay, my school and school science teachers, okay, use green box in school syllabus. this is also my students' production. Okay, so they love to use Green Box because Green Box not only only to reuse the burn fluorescent light, but you can use it as a automated light. Okay, so one of the example of my school students in exhibition.
Hi, I'm Amanda. I'm Gabriel. And we are from SMK Centrisa. So as you can see, this is a burn bulb. So with this device, you can actually reuse this burn bulb and this bulb can actually light up. So this is how it works. Yeah. That's it.
So that is example. Okay, so if you look at the brightness of the light, okay, if you compare the brightness, a new fluorescent bulb will give you 1200 to 1290 LUX. Okay, this is using light meter. Okay, normal light meter. Okay, with using a green box, a burn bulb will give you 419 LUX. This is only for 12 watt input. But if you want to increase to 1002, we can give 1002 LUX if we give more input, like we have to use 25 to 30 watt, then we can get 1200 LUX. So, but this 419 LUX is for dim light, actually, dim light brightness. Okay, so these are the next year's projects for my students. Okay, using green box, frequency versus LUX, frequency versus distance. Distance means the distance of the light from the resonant transformer, and then frequency versus current. Okay, so a lot of achievement in school. So this will be the yearly activity for Nature Club and innovation project in STEM clubs. Okay, and interactive activity for Form 3 Science. Okay, they can actually try. Is one of the project-based learning, and in RBT also we can use Green Box as an automated light, and also involve commerce student. Okay, this project actually filed for patent, but patent is not for the resonant transformer. Patent is for how to reuse the burn bulb by using resonant transformer. Okay, so these are the achievements for year 2019. Okay, we won Green Tech Design Gold, and then Green Tech Show Silver, STEM Green Tech Design, we have silver. Okay, a lot actually. So one international and one national. Okay, so these are the photos of my students and their achievements. Okay. So actually Green Box not only to we can use to reuse the burn bulbs, it can be also used to transmit wireless energy. Okay, this is the video. This is very recent, about 2 months ago. We tried. Okay. So resonant transformer actually can transmit wireless energy. You can see the LED. It will turn on. So this is similar concept with our wireless charger of our handphone. Okay, so that's all from me. Okay, so like I said in the beginning, okay, Green Box can use to reuse the burn bulbs. Okay, this is I hope all the school will try this project and benefit. Okay. Okay, that's all from me.
Thank you.
Any question?
Yeah, thank you, Teacher Sri. Okay,
Yeah.
now we would like to open the session for Q&A. Okay, for participants, should you have any question, please leave your question or type your question at the chat box here. then Teacher Sri can answer you accordingly. Knowledge, okay. So at the same time, let me check from the Facebook. Okay, there's a comment from the Facebook from Rahanatun, said sangat menarik on your sharing. Okay.
Yeah.
And
Actually
from
semua sekolah boleh buat project ni.
boleh
actually.
buat. True. Okay. And then very good, well explained, teacher with 3E knowledge. Okay, that's from Padmavati. And then from Mr. Sangara said it's a great sharing. Thank you, sir. Okay. So we will also, the video will also be in our Facebook. So if let's say you don't have any question currently, you can always post the question in our Facebook live comments, and we will forward it to Teacher Sri so that he can answer to your question accordingly. Okay. So, okay, Teacher Sri, you also have posted your email address and your handphone number, so you can be contacted directly.
Yeah. So if they want more explanation, can contact me. So any teachers here, if they want to do this project as their STEM club activity, they can contact me also.
Okay.
So no problem.
Good. Okay, participant. If you don't have any question now, it's okay. Okay, we have prepared a feedback form for the participant. We will paste it in the chat book here. So please kindly fill up the feedback form after the workshop, after the webinar. Your responses are very important in helping us to assess the effectiveness of this virtual symposium and webinar. Okay, so you can see we will also post the same questionnaire in our Facebook. So hope you can assist us to fill up the form. Okay, so in the Facebook, there's a few comment for Teacher Sri, congratulations and thank you for the sharing from Surya Kasim and from Nur Azila, Tahniah Cikgu dan Team.
Thank you.
Okay. All right.
Actually, what I want is actually if all the school, kalau semua sekolah buat project ni, so it will be very good for all the school because ramai yang tak tahu hazards of mercury actually. So we are already facing the issues in the fish, all those things. So memang kita the level of mercury in fish is very low, but if we continue in 100 years time, this could be the next pandemic.
Oh yeah.
So we have to start today. We have to start from now. So we have to educate the young generations to know about the hazards of mercury.
True. Thank you so much, Teacher Sri.
Yeah.
The sharing was interesting. We hope that next year, if we have the similar event, we would like to invite you and your team to share on your progress.
Sure.
Or if one day that e-KLESF will be able to conduct the physical fair in future, we will be more grateful if we can see you and your team to be part of our exhibitor during the fair.
Sure.
Thank you so much. Okay, before we ended the session, I would like to invite the participant to switch on your camera because we like to take a group picture with Teacher Sri as memory. So, okay, Teacher Sri, can you help me to stop sharing the screen first?
Okay,
so that
sure.
I can screenshot. Yeah. Okay, everyone ready? All right, we give few moments for the participant to switch on their camera. Okay, so if everyone is ready. Ya, kita ada 2 screen ni. Okay. So ready, smile, 1, 2, 3. Okay, let me paste it here first. Okay. One more. 1, 2, 3. Okay. Okay. All right. Last one, yeah. 1, 2, 3. Baru je. Okay. All right. Okay. Thank you so much, Teacher Sri, for your times, for your sharing. Thank you, participant, also to be with us today. We hope that you enjoy our session for today. This will be our last session for today. So we hope to see you again tomorrow. We will be back at 10 a.m. tomorrow with the workshop title Phyton and Pandas for Beginner, which will be conducted by our Utah lecturer, Dr. Anbu Selvan. So if you're free, please join us using the same link at 10 a.m. And for that, I wish you take care, all the best, stay safe. Thank you.
Okay, thank you very much.